Yes, I will deal about restoration, degradation and restoration of habitats to improve stock catch on marine ecosystems. Few general ideas before starting. This evidence for everybody, no stock recruitment. I just take few examples randomized from the ransom mice database, which is just evidenced the lack of link. And this is very old, very old pictures about the stock recruitment that just evidence the fact that if you made exception of the highly overexploited fish stocks, you've got recruitment drop before a drop in biomass, so recruitment drives stock strength, okay? This is why we're interested in stock recruitment for information today, for instance. The second general idea is that there is a huge level of dependency to estuaries and coast of many exploited species. In a high seas working group, which is called Value of Habitats for Exploited Species, we investigate that for almost 15 years. The group was held last week for this year in Hamburg. And the group evidenced that for the assessed fish stocks, you've got a little bit more or less than half of the species and 3/4 of the landings which rely on species which has at least one of the life stages that relies on estuaries and coasts. On these stages is mainly the juvenile stage, which is the case for 1/3 of species on 2/3 landings. And this result from the HICIS group are also evidence elsewhere from the US, from the Gulf of Mexico, and also worldwide. So it's more general. Okay. Last general idea, the impact, local impact in the nursery habitats of anthropogenic pressures on at habitat scale on juvenile fish. It can be the impact of habitat loss, pollution, eutrophication, invasive species. On the same group, a work that was head by Hilliot a few years ago. We evidenced that for more than 90% of the fish species investigated by HICIS, you've got these at least one pressure is evidence on at least one stages, mainly at juvenile stage. And for 3/4 of the species, you can evidence the impact of more than one pressure. So okay, we know what's happened in local habitats where juvenile are concentrated in estuaries and coast. You've got impacts of anthropogenic pressure. But the remaining question is what's happened for recruitment on spawning biomass at population scale. So what about the impacts of juvenile habitat disturbances at population management units for fish biomass productions on fisheries? This is what now it's called the offset ecological impacts, local pressure with local impacts, but consequences at dramatically wider scales. To try to investigate it, we developed during SEAwise a generic life cycle model. We looked the life cycle of the species and we focused on stock recruitment relation. As far as you've got in the lower left, the recruitment, it's not possible to adjust a stock recruitment relation for a given stock. And we just transferred the formulation of the Beaverton and Holt stock recruitment in a similar way, but formulated with two different parameters. The steepness, which is the level of, it's the shape of the curves. It's the level of decrease of the recruitment when the spawning biomass is decreased by a factor 5. And after you've got a carrying capacity, it's almost similar, totally similar to the Beaverton recruitment stock recruitment equations, but formulated in a different way. And the interest of that is that the steepness is adimensional, and there are plenty of studies that investigate it for different stock, different studies from huge databases like the ransom Myers one. So you've got species-specific estimates from really huge database of these parameters. After the carrying capacity could be estimated as a stock-specific parameters. So we use this formulation and we apply this model to case study in the Eastern English Channel, so called the Southern North Sea, perhaps for SEAwise, for 4 species. Okay, we've got this life cycle model. We want to focus on consequences of anthropogenic pressure on coastal habitats. We use 4 species, the whiting, the plaice, the common salt, the sea bass. We know the concentration, the level of concentration of these species on these shallow coastal and estuarine areas. We have also investigated the consequences of pollution on the lower density of juvenile fish in polluted coastal and estuarine area regarding Safe One. This has been investigated by huge database from the Water Framework Directive. And we also know from HIMODNet the level of nursery habitat loss from the latest 90th century. So you've got just an illustration here in the lower left corner for the same estuaries, but we've got this data for almost everywhere in the Eastern Channel. So the interest of this model is that we're able to infer the consequence of habitat degradation, lower density, higher mortality, on the steepness on the carrying capacity. So this is the interest of this, the second interest of this model. So this is what we have done, and of course this is a very classical stock assessment outputs. The black lines in the bottom is the present situation for a sea bass, from the duration from fish mortality to catches. And the other ones are the same, but if you restore just their very local nursery habitats. If you do so, sorry. Oh, okay. Yes, it's not okay. I understand what's happened. No problem. If you do so, you increase you a little bit change the level of fishing mortality at MSY, but you especially increase the potential catch, and you also increase the spawning biomass at MSY by a factor more than 50% just by restoration of local nursery for sea bass. If you try to enlarge the situation for the species, whiting, plaice, sole, and sea bass, it's different regarding the species, their level of dependency to shallow areas on their life cycle. But you've got different gains in tons at maximum sustainable yields, and different gains in percentage also of sustainable biomass. So you increase sustainable biomass, you increase catch potentials. Here, evidence at MSY, but it's also the case for others. You increase resiliency, lower risk of collapse, and it's also valuable for other species for which it was not estimated. We also applied this model to other case studies, like, for instance, the Irish sea sole. You've got this very recent investigation regarding the shallow habitat lost in the Irish Sea from Stump. So we applied the model also and calculated the loss of spawning biomass and catches regarding the surface loss of nursery habitats for the common sole. This is almost an offer. I think now the model is okay and can be applied to plenty of other case studies if you are interested in. So the take-home message, fish recruitment is the driver of population production future biomass. No new information from nobody. It depends for a large number of species on coastal and estuarine habitats, which are impacted by coastal and anthropogenic pressures. So this is the double winner experience of habitat restoration. Locally, you increase biodiversity, you restore habitats, and at the wide scale, you improve offset ecological ecosystem services, including fish population and fisheries. Thank you.
Thank you, Olivier. Our next speaker will